This video is for section 2.3 on linear equations in two variables. And what we're looking at in this section is equations that have two variables, x and y, and then three coefficients or numbers, a, b, and c. And we'll see some examples of this. The first question is to determine if this equation is linear, this equation. And what I want to point out before we work on this is that I've got an x variable and a y variable, but it's just x and just y. It's not x squared. There's no y squared. There's no variables in the denominators. These could be fractions, the a, b, and c. They could even be zero, some of them. But this one, it's hard to tell from looking at it, but if we simplify, we're going to be able to see that it's of this form. So what I'm going to do first is distribute the 9 and then combine like terms. There's two x terms that I can combine. Negative 8x plus 9x is 1x, or just x, plus 9y, and all that's left on this side of the equation is 3. That's exactly of this form. That's 1x, so the a is 1, plus 9y, so the b is 9, equals 3, so the c is 3. And yes, this is linear equation in two variables. I have another one that's similar to this. It's actually the same question. I'm just going to say linear. This time we're talking about the equation 2x plus 12xy equals 10y. And the answer is no, or not linear. I could bring this 10y expression to this side, but this has no place in a linear equation in two variables. X times y isn't one of the things that I can have in a linear equation. Non-linear is the word for that. So in this section, you're going to, in some of the problems, you're just going to have to identify equations, whether they're linear or not, and you'll see a few examples of each. Now the next problem is more involved with the connection between linear equations in two variables and their graphs in the xy plane. And the graphs represent the solution set of the linear equations in two variables. And as you might guess, from the name linear, the graphs are lines, or straight lines as they're sometimes called. What we're going to do in this one is find the x and y intercepts. So intercepts are special points on the graph, which is a line. In particular, there are special points where the graph crosses one of the axes. The first one we'll look at is, here's the equation. 8y equals 56. There's no x here, but you could think of it as 0x. So we can still treat this like an equation in two variables, even though the x, it doesn't matter what it is, it's multiplied by 0, it's not even there. What we're going to do in part A is find the x intercept, or x int for short. And to do that, I want to show you a graph. Now this is not the graph of the line here. We don't have to graph in this problem. We just have to find the intercepts. First the x-intercept. And I'm just going to draw a line to demonstrate what that means. The x-intercept is where the graph crosses the x-axis. So I'm really looking for that x value. Now what I use for that is the fact that up here the y values are positive, down here the y values are negative. So these y values along the line are positive, y values along this line down here are negative. right there, the y value is equal to 0. And that's what I use to find the x-intercept. Y equals 0 means that 8 times 0 equals 56. I just substituted the number 0 in place of y in the equation, and I'm gonna try and solve this. But this side simplifies to 0, and this side is equal to 56. That's not true. What that means is that there is no place on this line where y is equal to 0. There is no x-intercept. And so the answer here is no x-intercept. Or the x-intercept is absent, is another way to say that. So however Hawks is asking for your answer, it's probably a little box, a little bubble that you click. Another way to say, well, that's really it. There is no x-intercept. So I'm going to erase this part, and we're going to do part B with the same equation. Find the y-intercept. Now, let's look at a picture again. That last picture wasn't very good because I had an x-intercept in the picture, and there really wasn't an x-intercept. But the idea is sound. A y-intercept is a place where the graph, the line, crosses the y-axis. I want to find that y value. And to do that, I can use the fact that at that point, x is equal to 0. So over here is positive x's, over here is negative x's. Right along the y-axis, x is equal to 0. And in this equation, x equals 0 doesn't really mean very much. It means 8y equals 56. There's no 0 to plug in. But this one I can solve for y. If I divide both sides by 8, I get y equals 7. And so I'm going to write down my y-intercept. It's not y equals 7. The intercept is a point. I need an x, y pair. Now the y value is 7, but this is a point. This is an equation. We want the point where the graph crosses the y-axis, the y-intercept. The x value is 0. The y value, it turns out, is 7. And that's the answer. That's how you're going to have to put it into Hawks as an ordered pair. Another thing about this line, it doesn't have an x-intercept. So I do want to draw for you a better picture of this, just for reference. This is what this line actually looks like. I've got my x-axis and my y-axis. Up here at 0, 2, 3, 4, 5, 6, 7, 0, 7, that's my intercept. And y is always equal to 7. It doesn't matter what x is. Any value of x that you plug into this equation, there's nowhere to put it. What you get is 8y equals 56. That means that the y value is always 7, and this is a horizontal line. We'll get into that more later as we're graphing lines. All right. The next problem is also about finding intercepts. I think this is a little more typical and will probably go a little bit smoother because we're actually going to find one of each. But find intercepts. 5y minus 6x equals 15. And that's a linear equation in two variables. It's not how we had before with the x first and the y second, but you could move them if you wanted. This is fine like this. It's actually shorter to write. For part A, I'm going to find the x-intercept. And I'm going to use the same strategy I did last time. The x-intercept, it's neither above nor below. It's on the x-axis. That means the y-coordinate is 0. And that's what I use to actually find that x value, that x-intercept. So 5 times 0, because y is 0 for the x-intercept, minus 6x equals 15. I can simplify this quickly. 5 times 0 is 0. So this is really just negative 6x equals 15. I can divide both sides by negative 6. And I get x equals negative 15 over 6. Negative 15 over 6. But for Hawks anyway, you'll need to simplify this. Both of these are divisible by 3. So if I cancel a factor of 3 up here with a factor of 3 down here, I'm left with 5 over 2. Negative 5 over 2. Now that's my x value. The y value is what I started with. It's the x-intercept, so the y value is 0. So the x-intercept for this line is the point negative 5 halves, 0. And that's what you'd have to enter for a problem like this. Enter the x-intercept as an ordered pair. Let's go on to part 2. We'll find or part B rather. We'll find the y-intercept. And to find the y-intercept, similarly, this time we're going to set x equal to 0. Because the y-axis, we're looking for the place where the line crosses the y-axis, at that point, it's on the y-axis. Means the x is neither positive nor negative. The x is equal to 0. And that's what I'm going to plug in, substitute for my x value in this equation. Again, this is pretty quick to simplify because 6 times 0 is 0 and minus 0 doesn't change anything. This is just 5y equals 15. And then if I divide both sides by 5, I get y equals 3. Again though, that is not the intercept. The intercept is a point with y value 3, but x value 0. So the point 0, 3 is the y-intercept for this line. I think actually with this problem, let me put back up my x-intercept, negative 5 halves, comma 0. Part A, I think in this problem it was really to find both intercepts, and then part B was to graph. But you're going to have to graph this on Hawks. So the first thing is to find those 2 points. The second thing is you have to put them one at a time onto the XY plane that's provided. And you put the first one, it's just a point. But when you put the second one, Hawks completes the line. I'm going to do this one first. Negative 5 halves. So negative 5 halves is 2.5, negative 2.5, right about here. And negative 5 halves 0 is that point. That's my x-intercept. This one, 0, 3, is the y-intercept. And then once you place that second point, Hawks will complete the line, the picture of the line. So this graph, the graph of this line, represents all the solutions of this linear equation in 2 variables. I have another one like this, where we'll find intercepts and use them to plot 2 points to graph the line. For number 5, it's again, find intercepts. 4x plus 7 equals negative 4y plus 7. And I really don't have to modify it. This isn't the regular form of the equation in 2 variables. It's It's got the y over here and the x over here. It's okay, but since all we have to do is find the intercepts, I'm just going to do that. First, the x-intercept. How do I find that? I set y equal to 0. What that means here is 4x plus 7 equals negative 4 times 0 plus 7. I just replaced the y with the number 0. Now I'm going to simplify. This side doesn't simplify, 4x plus 7. This side, though, negative 4 times 0 is 0. So all that's over here is 7. If I subtract 7 from both sides, I get 4x equals 0. And divide by 4. 0 divided by 4 is 0. So what that means is if the y is 0, then the x is also 0. Now I can do this again and find the y-intercept, but it's not really going to help. Let's look at what it looks like anyway. The y-intercept, I'll set x equal to 0, so I have 4 times 0 plus 7 equals negative 4y plus 7. Simplify that, I just have 7 equals negative 4y plus 7. Subtract the 7, and I have 0 equals negative 4y, and finally divide by negative 4. So I get 0 divided by negative 4 is 0. Y equals 0. That really doesn't help. So what this part told me is that the x-intercept is 0, 0. X is 0, y is 0. This one tells me that the y-intercept is also 0, 0. That's great. The x and y intercepts are in the same place. Except that we need 2 points to graph, and this is 1 point. So we have to find a different point. What did I do? So I chose a different value for x, and I'm going to put that in and find the corresponding value for y. That'll give me a second point. Remember, 0, 0. I'll leave it down here. It's not that our intercept method here didn't work, it's just that it turns out the intercepts are the same point. We need a second point. So I'm just going to choose x equals 1 because it's easy to work with. There's some situations where you might want to pick a different x value. If you, for example, you have fractional coefficients, if you pick the denominator, it'll cancel. But in this case, x equals 1 means that 4 times 1 plus 7 equals negative 4y plus 7. I just replaced the x with 1. There's nothing special about this number. You can actually do any number you want. 1 just makes it simple. 4 times 1 is 4 plus 7 equals negative 4y plus 7. Or 11 equals negative 4y plus 7. And then if I subtract 7 from both sides, I get 4 equals negative 4y. And divide by negative 4 on both sides to get negative 1 over here and y over here. So with that, this is what I'm going to put back together. When I used x equals 1, the y was negative 1. That means the point 1, negative 1. X is 1, y is negative 1. Is another point on the line. It's not an intercept. But the reason I did this was for part B. We're supposed to graph. And 0, 0, that's great. That's the intercept. That's the x-intercept and the y-intercept, but it's still only 1 point. This gives me another point. X equals 1, y equals negative 1. There's a second point. Hawks is going to have a gridded xy plane. So there's a grid on here. You can more easily find where the two number lines, really, where the two of those vertical and horizontal lines intersect to give the coordinates for this point, but Hawks will do this for you. You don't have to trace the line. As soon as you plot the second point, Hawks graphs the whole line. So if it's asking you for the intercept, x-intercept or y-intercept, it's this one. But you do have to find a second point in order to graph that. Here's another linear. Is this equation linear? The equation is 5 plus y squared minus y squared equals 9x plus 6. And at first glance, this looks to me like it's not going to be linear because there's a y squared. But we can't tell. We actually have to simplify this expression to be able to tell if it's linear. 5 plus y squared is 5 plus y times 5 plus y. Not 5 squared plus y squared. Exponents don't distribute. We have to actually square 5 plus y. Minus y squared equals 9x plus 6. So I'm going to FOIL these, multiply these two expressions. The first gives me 25. The outers, this is kind of advanced for this part, but the outers gives me plus 5y. The inners gives me another, y times 5 is 5y. And then the lasts give me y squared minus y squared equals 9x plus 6. And if I simplify that, I can cancel those two, y squared minus y squared. And I can combine these, 25 plus 10y equals 9x plus 6. Now I'm going to sort things according to the ax plus b. Ax plus by equals c. That's the, if you can put it in that form, it's linear. And I'm about to. What I'm going to do first is subtract 25 from both sides to get 10y equals 9x minus 19. And then finally subtract 9x from both sides to get negative 9x plus 10y equals negative 19. That's not really the answer, but that's the simplified or the standardized form of this equation. It's an ax plus by equals c. It is linear. So the answer to this problem would be yes, it's a linear equation. But I couldn't tell that from the start. I had to simplify to be able to see that it's of that form. The next one, number 7, is again to find intercepts. This time for 9y plus x equals 9 plus x. For some reason it gave me this expression in parentheses, but those parentheses really aren't doing anything because there's no multiple or negative sign or anything. In fact, I'm going to rewrite it as 9y plus x equals 9 plus x. That'll do. Find intercepts. So first, let's find the y-intercept. To do that, I plug in x equals 0. So that means 9y plus 0 equals 9 plus 0. Replace the x's with 0. So 9y equals 9 and y equals 1. So my y-intercept is 0, 1. The y value is 1 when the x is 0. I'm going to leave that part down there because that's one of my intercepts. But The other thing we need to do is try to find the x-intercept. And that's when y is equal to 0. That's going to mean 9 times 0 plus x equals 9 plus x. All I did was replace the y with 0. 9 times 0 is 0, so this is just x equals 9 plus x. And this isn't going to be good. If I subtract x from both sides, I get 0 equals 9. That's just not true. What that means is there is no x-intercept. So, no x-intercept. So this was my y-intercept. But there is no x-intercept because this is a horizontal line. It doesn't go up or down. It goes horizontally flat. So it doesn't come down to the x-axis. So no x-intercept. For number 8, it's another, is the equation linear? So here's an equation in two variables, 9x times y plus 3 equals 2 minus 9y times 6 minus x. Is that a linear equation? It's too complicated to really tell from this situation. What I'm going to do is simplify both sides by distributing 9x times y is 9xy, 9x times 3 is 27x, 27x, 9x times 3. And that's equal to 2 minus 9y times 6 is 54y. And then 9y times x, that's 9xy. But this is a negative times a negative, meaning that's a positive 9xy. So all I did here was distribute on both sides. Now I'm going to try and combine like terms. There's no like terms over here and there's no like terms over here, but I do want to get the variables on the left and the number on the right. There's the number. It's the only number here. Here's some variables. Here's some variables. Let's start with subtracting 9xy from both sides. You could also add the 54y to both sides, but I'm going to do one at a time. Here, I'm left with 27x equals 2 minus 54y. Because the 9xy cancels here and the 9xy cancels here, it's gone. Next, I'll add 54y to both sides. And that's 27x plus 54y equals 2. And that's a linear equation. ax plus by equals c. The answer is yes, it's linear. The next one is similar. Number 9 asks if 11x plus y over 5 plus 8y equals 3. Again, it's a little hard to tell just from looking at it if it's linear or not, but I want to do something here that's going to be a helpful technique in this section, but also in the future. When we have fractions, it's just one more complicated thing to work with. And if you keep the fractions, it's in every step. But what we can do is multiply both sides. This whole side times 5, and well, this whole side also times 5 to keep it balanced. And that's, I'll write this out, 11x plus y over 5. That needs to be multiplied by 5. Also, the 8y needs to be multiplied by 5. I'm distributing this 5 to these two expressions. Over here, it's just 3 times 5. And the reason for that was that having multiplied by 5, those 5's cancel. I'm left with 11x plus y plus 5 times 8 is 40. Y equals 15. And if I combine these two like terms, 11x plus 41y equals 15, that is linear. So it didn't look like a linear at first. We had that fraction expression, but when I simplified it, it's just a linear equation in 2 variables. And finally, number 10 is another find the intercepts problem. So, 10, find intercepts. 7 minus 4y equals 11 minus x is the equation. For the x-intercept, you don't have to find these in a particular order, but for the x-intercept, we set y equal to 0. For the y-intercept, you set x equal to 0. In particular, for the x-intercept, you set y equal to 0 and substitute it into the equation so you can solve for x. That'll give you the x-intercept. 4 times 0 is 0, so 7 equals 11 minus x. I can subtract, there's more than one way to do this, but if you subtract 11 from both sides, you get negative 4 equals negative x. And divide by negative 1 or multiply by negative 1, you can even just cancel out the signs. 4 is the x value. In other words, x equals 4. That's not the intercept, though. That's the x value of the intercept. The intercept is 4, 0. The y value is 0. The x value is 4. That's my x-intercept. We're going to find the y-intercept in a similar way. This one didn't mention graphing, so I think we just have to find it. That's the x-intercept. The y-intercept means that I'll plug in x equals 0, which means 7 minus 4y equals 11 minus 0. Or 7 minus 4y equals 11. Subtract the 7, and I get negative 4y equals 4. Then divide by negative 4. Y equals 4 divided by negative 4 is negative 1. That gives me the y-intercept. The y value of the y-intercept is negative 1. The x value is 0. Always the x value of the y-intercept is 0. But there's the other piece that we're supposed to find for this problem.